Hello everyone. So I'm back to making Leetcode daily challenge videos, and there will be videos every day from now on, every day morning. Okay, so yeah. So let's see today's daily challenge, and we will try to solve it together. So we have this problem, binary watch. It has 4 LEDs on the top to represent the hours and 6 LEDs at the bottom to represent the minutes. Okay, and it looks something like this. So if the binary, if you want to read something like 451, then you have to see that the 4 button is glowing over here, and since there is no 51, if you add up these digits it will become 51. Okay, so if you add up 32 with 16 and with 2 and 1, if you add all these digits, 32 plus 16 plus 2 plus 1, you get 51. Okay, so that's how. So basically it is just a binary representation. You can just think that the glowing digits are the bits which are set, and the off digits are the bits which are zero. Okay, zeros and ones. So and it is just told that in the returning like the answer which you need to return in the format, how you need to return. Okay, so let's say you want to return 1 o'clock. So 0100 you should not do, you should do 100. Okay, and similarly if you want to return 2 minutes after 10, so you should not you should make sure that the trailing zero is there after before 2. Okay, so if it is a single digit number. So that's how. If you see this example, turn down it's 1. Okay, so you will be given one integer turned on. It represents how many bits are turned on. Okay, how many LED bulbs are glowing on. So if it says that if only one LED is glowing, so what can it happen? It might be true that in the hours section all are off, and in the minute section any one is glowing. And it can be also true that in the minute section all the LEDs are off, and in the hour section any one is glowing out of the 4. Okay, so all of those possibilities, if you take care of, what is the possible times which can represent in the clock. Okay, so that's what you need to give as the answer. And yeah, you need to return the answer as a vector of strings. So let's see. First of all, why there are just 4 digits and 6 digits representation? Why not more or less? First thing, did you understand this? Okay. So you want to represent hours and minutes, right? So let's say you want to represent hours and minutes. Okay. What is the range of this hour? It will vary from 0 to 11. It is told in the question. Okay. 0 to 11 it is ranging from. And the minutes will range from 0 to 59. Okay. So how many bits you need to represent this? So let's say if I tell you you have 3 bits. So maximum number which you can represent is 111, which is nothing but 7. So binary 111 is nothing but 7 in decimal form, right? So up to 7 you can represent in 3 bits. Okay. So using 4 bits, how many maximum can you represent? You see, you can represent 15, up to 15 you can represent. Okay. So total number till 15 you can do. So you see, you need till 11. So 4 bits, that is the reason why you need 4 bits to represent the hours. And similarly, if you think of the minutes, you need 6 bits, because uh, if you think of like this, there's a number, binary number, where all the 6 bits are high. Okay, so what will be that number? Okay, that will definitely be more than this. Okay, so if it is something like 7th bit, so you know that this number is just one less than this, and you also know that this is nothing but 0 1 2 3 4 5 6. So you have 2 to the power of 6, which is nothing but 64, right? So if this is 64, this definitely means 63. So yeah, till 63, if you are able to represent using 6 bits, so it is fine. You till 0 to 59 you will be representing all numbers, so you need just 6 bits for this. So I hope you do understand at least how does that mean. Okay, and it is nothing but bits, as I told you. If the LED, if there are 4 LEDs, if the first one is glowing, second one is not glowing, third one is glowing, fourth one is not glowing. It simply means that it is the binary number 1010. Okay. And if you try to convert this to decimal, it is nothing but 10. Okay. Why? Because you see, this is nothing but 2 to the power 0, 2 to the power 1. Okay. Again, this 2 to the power 2, 2 to the power 3. So 1 into 2 to the power 3 plus 1 into 2 to the power of 1. It is nothing but 8 plus 2, which is 10. So that is why this is the binary representation. So how can you solve this problem? You see, you need all possible time. Okay. So if you see, you can iterate through all these times. Okay. So if you try to see from 0 to 11 and 0 to 59, you can have two loops. Okay. So for loop, let's say you have a I loop which goes from 0 to I equals to 11, and you have a j loop which goes from j equals to 0 to j equals to 59. Okay. And you just see that what is the total number of bit sets. So if let's say for I, you see, let's say you see, you check that I is nothing but 11. Okay. Now you know that the binary representation of 11 is something like this. Okay. So you see that there are three LEDs which are turned on. Okay. So let's say x equal to 3. There are three LEDs which are turned on. Similarly, for representing j, let's say you find out that there are four LEDs. Somehow you find out that uh, there are four LEDs which are turned on. So if you add these 3 and 4, you get 7. So total of 7 LEDs. So you just check that if your variable turned on is nothing but 7, then you add to your answer, then you add the current time to your answer. Otherwise you do not. Okay. So once again in a structured way, if we just talk how to solve the problem, you can just have something like this. From int 0 to 11, you just calculate an x. Okay. How will you calculate this x? You can calculate this x by seeing that how many set bits. So it just says that how many bits are set in I. Okay. That is nothing but x. And for j also you can traverse and check from j equals 0 to 59. Okay. And you can have some integer y. In this y, you can just check that how many bits are set in j. Okay. Now you just check, you see, total number must be turned on. Okay. So turned on represent the total number of bits. Okay. It is already told in the question. So if x plus y, total number of bits, is equal to turn on. Okay. If this is true, then what you can say, you can add to your answer. Okay. Add the time to your answer. So just add the time to your answer. Okay, so that's how you can just do this, and I hope there should be no issue at all, provided you follow all the rules which is told in the question. So yeah, let's try to code that out. Let's try to code it out. I hope this will be simple, and if you have understood the solution, you can just simply go ahead and code it out on your own. No need to watch this video come till the end also. Okay, so if you are not able to do, then I will suggest, then definitely go on watching the video. So we have this vector string answer. Okay, so this is our answer which we will have put our values in. Okay, and we have the int I equals to 0, I less than equals to 11, I plus plus, and so this represents the hours. Okay, I represents the hours. So I is nothing but the hours. Okay, and we also need another loop j, and j will go from 0 to 59. Okay, and j represents the minutes. It's as simple as that. So it represents the minutes, and you just need to now check all the values. How many bits are set in I? How many bits are set in j? Okay, so how will you calculate that? Let x represent how many bits are set in I. So let's say, see how many bits you have in I. Maximum you can have 4 bits set. Okay, but yeah, just check the bits one by one. So let's say bit 0 to bit, see this, we call this bit 0, bit 1, bit 2, bit 3. Okay, so for 4 bits we have 0 to 3. Okay, so bit number 0 to bit number 3, if you just see. And I hope you know this in bit manipulation, how to check whether the bth bit, so bth bit is set or not. One left shift b and with I. Okay, So this is the way of checking that whether the zeroth bit or the first bit or the second bit or the third bit is set or not for this number I. Okay. So if you don't know this, I will just tell you once again. Uh, if you have a number n, okay, let's say the number is something like this, and you want to check this is the zeroth bit, one bit, two bit, and you want to check whether the second bit is on or not. Okay, 2th bit is on or not. Okay, so what you will do, you will do one left shift two. So one left shift two means if one is this, you left shift one by two, so if one will come here. Okay, one will come from here to here. So one left shift two, what is the number you have? You just AND with n. Okay, so this is the number one left shift two. Okay, this is n, and this is the number one left shift two. If you just try to perform an AND operation, okay, you see you will get a one. Okay, so you get a one. And if you see, let's say if this bit was not set, you will get a zero. Okay, so if this bit is set, you will already get a one, and you can just increment your x. The same thing, the exact same thing you can do with y also. Let's say you are trying to count an integer y. Okay, so uh, this y represent how many bits are set in this minutes. Okay, so for this, see, you have 6 bits, right? So 0 to 5, and if this bit is set, you just on this y, and yeah, you can just do something like if x plus y total number of bits set is turned on. Okay, then you add to your answer. Okay, just add to answer. Okay, now you see what are all the things which you need to add to your answer. So let's have a string result. Okay, what will be this result? In this string result, what we will do, just answer dot pushback result. Okay, so I hope you do understand, and at the end we can simply return. Now how will we form this answer? How will we form this? Okay, so you can check that I can do simple to string of I. Okay, to string of I. So I can just initialize my result with this. So what does it represent? So how do we need to set the result? So for 451, I need to do 4 colon 51. Okay. So first is the minute, first is the hours, and then is the minute. Okay. So I represent the hours. So I just save this hour inside this result right now. And after that, what we require is a simple colon. So I have this colon with me. Okay. After this colon, what we need an optional zero. You see, if we want to say it's 2 minutes past 10, so we need a zero too. So that zero we will take care of. So how we will take care of? If j is less than 10, if it is a single digit number, okay, then you add a zero. If it is a single digit number, you add a zero. Okay, to your result, and then what you can do simply to string of j, you just add j. Okay, and this is your result. And if you see, if you find this x plus y equals to turn on, it means that if the total number of bit sets is just simply turned on, you can just push back that result into your answer and simply return answer. Okay, so let's see if you try to run this. Okay, so let's debug. No matching function to call for toString. Okay, so you see, toString is a thing which converts an integer from a string, but this thing is already a string, right? So you do not need a function for that. So let's see now. We have some bug or not. Okay, so we do have the accepted thing. If you try to run this for all test cases, will it work? Let's see. Yeah, see, it works and it gives a perfect 100% runtime bits. So yeah, that's all, I guess. That's all for this problem. If you think it in the correct way of trying to find all possible times and then seeing how many bits are set, and if the bits total number of bits set are turned on, then you can return the result. Okay, so if you think in the correct way, this problem becomes really simple. Yeah. So that's all for this video. I will meet you in the next video. Till then, thanks a lot.